A man with a height of 2 meters walks at a constant speed of 2 meters per second towards a street lamp with a height of 6 meters. At the instant the man is at a distance of 12 meters from the base of the street lamp, find the rate at which the A, length of his shadow changes, B, tip of his shadow moves relative to the street lamp. We have a triangle forming here because we have a street lamp and we have a man, and the light from the street lamp that just passes above the top of the man's head and strikes the ground is responsible for forming the length of the man's shadow. The man has a constant height of 2 meters. We can label that on the picture. The street lamp has a constant height of 6 meters. We can label that on the picture. The man's distance to the street lamp is changing here, so we need to label that as a variable x, and therefore the length of the man's shadow will also be changing. Let's label that as y. We're given the rate at which the man is walking towards the street lamp. Since he's walking towards the street lamp, his distance from the street lamp, which is x, will be decreasing. So its rate, x prime, or dx dt, will be a negative number. And we're given the value of 2 meters per second. We want to look at the instant the man is at a distance of 12 meters from the street lamp. That means x will be 12 meters, but we do not want to label that on the picture because that 12 meters is not a constant. The man is changing his distance by walking towards the lamp. That just tells us the instant at which to calculate the values. For part A, we want to find the rate at which the length of his shadow changes. The length of his shadow is y. The rate at which that changes will be y prime, or dy dt. We have the rate of x prime dx dt. We want to find the rate of y prime, or dy dt. We need to relate y to x. Y and x are related to each other by similar triangles. We have a smaller triangle whose angles are exactly the same as the bigger triangle. Similar triangles have their sides in proportion to each other. So the base of the smaller triangle, y, to its height, 2, y over 2, equals the base of the bigger triangle, x plus y, over the height of the bigger triangle, which is a 6. There's our related variables equation, though we can simplify this. Let's cross multiply. Multiply both sides by 6, so the 6 comes up to the left side. Multiply both sides by 2, so the 2 comes up to the right side. And this is also true. And we can distribute the 2 ends, so we have 6y equals to 2x plus 2y. We can subtract 2y from both sides, so we have 4y equals to 2x. And we can even divide both sides by 2, so that we have 2y equals to x. There's our simplified version of the related variables equation. We can now relate the rates by taking the time derivative of both sides, indicated by a prime on both sides. Every variable is implicit with time. Every variable will get a prime when we take its derivative. On the left side, the derivative of 2y is 2, but then times y prime due to the chain rule. On the right, the derivative of 1x is 1, but then times x prime due to the chain rule. Every variable gets a prime on it due to the chain rule because every variable is implicit with time. There's the related rates equation. We have x prime, so we can now plug our numbers in, and 2y prime equals to negative 2, dividing both sides by a 2 gives us y prime equals to negative 1. Therefore, y prime, or dy dt, is equal to negative 1. It'll have units of y. Y is a length. It's therefore in meters. Over time, time is measured in seconds here. So there's the rate at which the length of a shadow changes. Y prime, it's negative 1 meter per second. Apparently, it's becoming shorter. For part B, we want to find the rate at which the tip of his shadow moves relative to the street lamp. If we look, the tip of his shadow, which is out here, relative to the street lamp base, which is over here, those are apart from each other by a distance of x plus y. So the rate for that will be x plus y quantity prime. Well, since these are added, we can add the primes of each, because the prime of a sum is the sum of the primes. And therefore, it's just the summation of x prime plus y prime, which comes out to a -2 minus a 1, or -3. And therefore, x plus y prime is -3 in units of length, meters over time, seconds. There's the rate at which the tip of his shadow moves relative to the street lamp.